Hello, fellow educators. It's Dr. Hoban. Welcome to week 2 of our course. Now, this video is actually going to cover your assignments for weeks 2, 3, and 4. So I'm going to say a lot of things at you, but it's going to set you up for success for those 3 assignments because you're doing basically the same thing in all 3 of them with 1 little shade, 2 little shades of difference. So let me walk you through all of that now. So really important before I even start that is let's try to make these assignments work for you, for your teaching situation or your scenario, so that this is like an authentic task that you're doing that might be something you could actually use. So what do I mean by that? So some of you have indicated that you only have 25 minutes to teach science. Cool, then we're going to work with 25 minutes. So that's all you need to do. For everybody, this doesn't need to be a big complicated thing as we get to this assignment, so please keep that in mind. 1 25-minute lesson will work for each of these assignments. So do you have to integrate science? Maybe you can't teach science separately, which is the case for some people. So how could you integrate with math, reading, or English language arts? I'm going to show you where to find the next generation science standards that give you the integrations with math and ELA so that you could again, be authentic when you're creating these lessons with something you might actually use. Make sure before you start these assignments that you watch the video presentations and you at least skim the readings, because it's really evident when folks haven't done that because you're not integrating the things into the lessons that I'm looking for. So we'll talk more about that in just a minute when we look at the directions. So make sure you do those things first before you jump in. These are next generation science-based assignments, so you have to get familiar with the next generation science standards, and the lessons you're going to create for these assignments are supposed to be inquiry-based. So we're going to give you the information you need for that, but you've got to look into it first if you're not already familiar. Okay, speaking of inquiry-based lessons, let me talk about that for a minute because there can be some misconceptions around that. Sometimes small tweaks to what we're currently doing can make a huge difference. So let me give you an example of how we can go from our typical topic-based instruction and make a small tweak to go into inquiry-based learning. So a common topic that we teach is ocean habitats. So when we teach traditionally, we tell students, okay, our next topic is ocean habitats. And when you do that, it tells the students that they're going to be told information about ocean habitats. There's probably going to be some vocabulary words that they're going to write down and define, and then you're going to give them some information that they're then going to return to you on an assessment. See how that's very like passive learning? The students are getting everything from someone else. What if I made a tiny tweak to that? I mean, you guys, tiny. What if instead of saying our topic is ocean habitats, what if I started by saying, how is it that sea turtles can live in the ocean where sharks live and the sharks aren't just eating everything? What? Can you see the difference that a student would have between I'm going to tell you about ocean habitats and why don't sharks eat everything in the ocean? That tiny tweak alone is huge. So this is inquiry. So notice I'm starting with a question. So now you're getting students wondering and they're thinking about, yeah, wait, why don't sharks just eat everything in the ocean? So I'm still going to teach you about ocean habitats. But now I've presented it, I've kicked it off in a way that's much more engaging for students, and it tells them that they're going to need to figure out an answer to a question, and that's kind of, a good entryway into inquiry-based learning. We're going to start where you are because you're all at different places in how you teach science. So if this whole concept is new to you and you've been doing very traditional science teaching, if you even just tweak to start with a question, you're making a big change that's super important. For those of you further along or familiar with the 5 E's, this is the engage portion of the 5 E's. So remember, these are inquiry-based lessons, so I need you to have student-centered activities where the students are figuring something out, not that we're starting with vocabulary and then you're going to do a lecture or they're going to read something so that they can answer questions. That's not inquiry-based. So I'm going to challenge you to create inquiry-based learning activities for your students for these. It doesn't have to be complicated. Inquiry-based is not like doesn't have to be a whole huge project. Don't make this harder than it needs to be. 20 to 25-minute lessons will work. It's really more about the quality of thought and the depth of thought that you're engaging students in that makes it inquiry-based. So think student-centered. How am I making the learning active? And you're going to be well on your way. Now, if you have not tried Mystery Science, I'm going to recommend, especially if this type of teaching is new to you or if you have any concerns about it, try Mystery Science. It's great. All of the content most of the content is very short, little bite-sized pieces of science. It's broken up by grade levels, by topics, and so forth, but they start with a question, and then they might have a video and so forth. Right now, last time I checked, you could get Mystery Science for free for a year for individual use. It's worth signing up for it if you teach science at all, or just sign up for it for this class, because you can pull all 3 of your assignment lessons from Mystery Science. So I do highly recommend that, and that will be a link to that on the Padlet. So I'll put a link for a Padlet for you along with this announcement. The Padlet has other resources you can use to find lessons for assignments 2, 3, and 4. So now let me talk about assignments 2, 3, and 4. So I'm going to use the module 2 assignment directions, but keep in mind that the directions you're really doing the same thing. So what you're doing in each lesson or each assignment is you're creating a lesson. One of them will be for physical science, one for life science, and one for earth space science. When you're looking at the next generation science standards, PS is physical science, ESS is earth space science, and LS is life science. So make sure you're selecting the correct type of disciplinary core idea so that you're in the right content area for each. So our first one is physical science. I'm going to actually read to you from the directions so I can highlight some things as we go. Do not miss out on the very first part of the instructions because we give you a really important link there, and then we give you a different link later that's not as helpful. So at the very beginning of the instructions, it says, for this assignment, you will review the next generation science standards and identify physical science topics. Next, you will select one topic and so forth. I'm at the very top in the directions. Use that link. The next time they say in step 1 to access the topic arrangements, that's a 100-page document that you can then scroll down through and find your grade level. But if you use that first link in the instructions, you can actually divide it out much more easily because it has drop downs to divide it out by grade level and so forth. So use that link. Okay, so bottom line, step 1. We're going to the physical science standards and you're picking a standard. So this is key in step 1. You have to pick a next gen science standard in physical science, and that's what you're going to use for your lesson. Now, if you want to go play with Mystery Science or one of the other websites that I give you, go there and find a lesson that you like first that's physical science related, and then get the standard from that lesson. So you could do it either way, just depending, how this unfolds for you. So you do need a next gen science standard for this assignment. For 2, it says select an elementary grade level and 1 physical science topic for your presentation. So, for example, forces and interactions, pushes and pulls is a topic, so that will be in line with the lesson. Okay, 3, we give you a lesson plan exemplar to help you lay it out, so you can use that template for how to lay out a lesson plan. Again, you're doing this for assignments 2, 3, and 4, same steps, just different topics. Okay, now step 4 is where it gets different in assignment 2. You're going to create a PowerPoint presentation. You're not going to do that in assignments 3 and 4. Okay, just in assignment 2 is there a PowerPoint. In 3 and 4, it'll just be a lesson plan. But you're still writing a lesson plan for assignment 2. You're just putting it into a PowerPoint presentation with a couple of additional tweaks. But still, what you're creating within the lesson plan itself is the same for assignments 2, 3, and 4. Okay. Addition of a PowerPoint presentation just for assignment 2. So when it talks about what to put in your presentation, that's really what you're going to put in your lesson plan for all of the assignments. So now, a couple things important. When it says an introduction slide Actually doesn't say a conclusion. Okay. When it says an introduction slide, and then when you do assignments 3 and 4, it'll say an introduction and a conclusion. You guys, this is so important. Keep in mind that the main idea of these assignments is not just the lesson plan. Your teachers, you should be able to come up with a lesson plan, right? The key is what research or scholarly evidence or evidence-based practices are guiding you in creating the lesson plan. That's the key. Think of these as little research papers that have, maybe a lesson plan attached to it. You have to show me that you're using evidence-based practices by citing the research that told you why to build your lesson that way. That's what you put in your introduction. This one doesn't say a conclusion, so you're going to have to put all of that in your introduction or in your conclusion for the others. But the introduction and conclusion is key to these. Do not leave that out, because that's where you're going to tell me the next gen science standards say that we should teach science in this way because blah, blah, blah. Citation, reference page. So that's where your research goes. You need research in all of these assignments. Okay? So going back to assignment 2, in your PowerPoint, you've got an introduction with your why behind the what. What is the research that's guiding your choices? It says a slide with an inquiry-based interactive project, learning activity, or online simulation incorporating critical thinking skills. So this is your activity for the lesson. Remember, doesn't have to be complicated. Please don't do a week-long project here. Pick one lesson. It could be 30 minutes or less, but inquiry-based. You need a slide explaining a literacy strategy. So do you want to use a trade book? How do you want to make that work? A slide explaining a technology application. Simply reading a book online is not a technology application. So remember, as you're looking into the next generation science standards, using technology is more than just being a consumer of it. So how can students, actively use technology? A slide explaining an engineering application. You will learn about that in the readings for the module, in the videos for the module. The science and engineering practices will be in the next generation science standard. So when you pull up a standard, make sure you're reading the whole thing, because it will give you the science and engineering practice that goes with the standard, and you want to incorporate an engineering application. An engineering application is when students have to solve something. They're trying to solve a problem. So you're not giving them something, they have to figure it out, build a solution. It doesn't have to literally be built. So they can be designing a solution to something, but they should be designing something or solving a problem. A slide explaining appropriate assessment ideas, something appropriate based on what they did. And then a slide explaining the type of thinking skill required. This one's kind of weird. I mean, you can go with critical thinking, or you can say they're doing an engineering design process that involves thinking through the design process. I mean, it's up to you. As long as you address thinking skills, I'm good. And then make sure you have your references on a slide for your, because notice you need references, because you're going to put in your introduction or on your slides. But somewhere you have to have citations telling me why you're doing what you're doing. So the lesson plan is the kernel, but wrapped around that needs to be the explanation about why you built the lesson the way you did. Okay? Because, let me refer you to the rubric so you can see why I'm harping on this. So if you go to the rubric, in the first one, that one's kind of clear. You addressed all the elements of the assignment. So if you leave out an introduction, you haven't addressed all of the elements of the assignment. So keep that one in mind. But then the big one I want to draw your attention to is the next one that says analysis, evaluation, and use of evidence to support presentation. Analysis, evaluation, and use of evidence to support presentation. So this is where you've got to have the research, because then for mastery, it says you clearly addressed the problem, but then you demonstrated scholarly analysis and evaluation, and you demonstrated connection to theory and or research, and then you correctly used a variety of scholarly evidence, and then you cited the literature beyond what was in the course. You can start with what's in the course, but you can use other things. Then notice again that this comes up in professional delivery of the product or presentation. You do not have to record this, you guys. You just have to make a PowerPoint presentation. No need to record it. You can if you want, but no need to record it, so the rubric makes it a little confusing. But it does say applied all required elements of the assignment in the deliverable. So make sure you've hit all those bullet points so I can give you all the points. So that's why, so I'm thinking ahead to the rubric when I tell you, hey, make sure you've got your scholarly evidence in there to back you up. So I know this was a lot, but you're going to do, remember, the same thing in assignments 3 and 4. No PowerPoint in those, but you're still going to write a lesson plan, and it still needs to be backed up by the research. So I hope this gives you a little more clarity around what we're doing. I hope you have some fun with this. There's so many cool inquiry-based lessons out there. So again, check the Padlet that I will also put in this announcement. There are some websites you could start with, and try Mystery Science if you haven't, and let me know if you have any questions. And I'm super excited to see what you do with this. Thanks, everybody.